Good morning, everybody, and thank you for joining our webinar today. The topic being covered is lifting solutions for building with Rothoblaas. Um, Throughout the presentation, if you have any questions, if you're on a computer at the top bar, you should see a Q&A button that you can click and you can type into. If you're on a phone, on the bottom right-hand corner, you should see three dots to open up that menu and find the Q&A button to type in your questions throughout the presentation. We will answer all questions at the end if there are any. And without further ado, I'm going to let our local technical consultant, Alex, take over. Alex.
Thank you, Chris. Hello, everybody. Good morning. My name is Alex. I'm one of the local tech consultants for the US, and today we're going to be talking about lifting solution for building with Rothoblaas. And so, let's get right to it. Give me 1 sec. There we go. All right. So, when it comes to lifting solutions, there's a couple things we need to consider. Two things that, the main things, and then we're going to go break into sections. So when it comes to handling or rigging, especially when it comes to timber, you have to consider two things, the fasteners and the rigging connectors. So for fasteners, there's a couple of things you have to answer, mostly the three W's and one H, and that is where to install them, how to install them, when to install them, and what fastener are being used. Because obviously you want to make sure the fastener you're using is not only the the right certification, but also you're using them in the proper setting. Um, because obviously you're going to be lifting probably 100,000, maybe in a 10,000 pound of wood, and so you have to make sure that when using the screws, and using the right ones. And lastly, you also have to consider about the rigging connector. Especially here in the US, there's a couple certifications you have to comply with. I'll talk about it more after this slide, but you have to consider if it complies with the certification when it comes to rigging. And also the same as before, you have to know where you're installing them, when, what, and how to install them. Because obviously you want to make sure you don't want these connectors to fail. You want them to be used 100%. And so when it comes to verification and compliance, there's two things we have to consider. One of them being ASME BTH-1. This is just a certification talking about the design below the hook lifting device, such as two of our products, mainly our Raptor and our WASP. These devices or these connectors, they must be used no more, no more than 20,000 load cycles, meaning that you can use these Raptors, you can use these connectors for up to 20 load cycles. You can lift them up 20,000 times, but after 20,001, you have to stop and say, okay, maybe it's not a good idea to keep going. Um, and then the other certification you have to consider is OSHA 1926.753. Um, what is this? OSHA standard? It's just to show that we have to make sure that the capacity that we say it's a safety factor of 5, meaning that we have to make sure that if we tested the connector and it lifted up to 10,000 pounds, we have to apply a safety factor of 5 to it to reduce it to be on the safer side. It's similar to ASD, where we apply a safety factor to the mean average, to the average value. Um, it's just so that way, no, we're being towards the safe and avoiding any chance of the connector or the screws failing. And so, speaking of the safety factor, it is mentioned in our ICC report, and that is that all screws that are ICC certified under our ESR 4645, all of them are certified and have a safety factor of 5, as determined by the committee of the ICC. You can have a look at our website to download a report for free, and you're able to see and which of the fasteners are being used for rigging, and also which has a certification as well. And it's very important that they're ICC certified, or there's some sort of compliance, because when it comes to rigging, you have to be on the safe side, and I'm a very safe guy, so I'm always trying to make sure I emphasize that we're not pushing the Raptor to its limit, we're not pushing the WASP or any of the rigging connectors to its limit, because the last thing you want is to rely on hope. And when it comes to rigging, you don't want to rely on hope, you want to rely on uncertainty. So there's that. That's just going for the screws and the connectors. But then let's talk about the other, how they're being lifted, like how they're connected to. And there's no limit. I mean, there's no like set, like this is what you have to use to lift our rigging connectors. You can use either a spreader bar to a chain sling, whatever gets the job done. However, it is always important, and always important, is to make sure that when rigging, is always statistically determined. So what does that mean? It just means that all forces are spread equally, and they're being and all of the slings are being lifted up equally. Um, and this is based on just seeing if the chains are, meeting our intention. If one chain is not taking as much force as possible, what might end up happening is that if you design, if you use four rigging connectors, for example, and you say that all four of these must lift a total of 10,000 pounds, and one chain is not in tension, you're probably only lifting 8,000 pounds, 8,000 pounds instead, when the panel weighs 10,000 pounds. Now you're in danger, you're lifting that up, and you're running the risk of either the chain failing or the COT panel falling on you, and you don't want either of those to happen. And so it's always important to make sure um, everything is determined, everything's statistically determined. Um, and always make sure that to find the center of gravity of those panels and those beams. Um, you can easily plug those into an AutoCAD. You can and it can do the math for you, or sometimes you can just another way just to evenly space them out. Like if, for example, like this at this panel, you can see that there is equal, symmetrical. Like they're being lifted symmetrically, and so you don't have to worry about doing any extra math. However, there comes to a point where maybe there's a hole in the middle, maybe there's something on the edge of a panel or a beam. Then that's when you have to find the center of gravity and space them out evenly. So usually what I always tell clients and customers who wants to use rigging connectors is to find the center of gravity and go about a third of from each side. Um, so if it was a beam, it's 60 inches. Go one third from the edge. So meaning that place the rigging connector 20 inches away from the edge, and then the other side do the same as well, 20 inches away from the edge. That way you're keeping a distance as well. So what kind of rigging connectors to use when it comes to this? Um, well, we have two. Two of our main ones are the Wasp and the Raptor. Let's first talk about the Wasp, which is the gray little guy right here. And there's just some pictures of how they're installed. So the Wasp is it relies on the screw and being connected to the connected to the Wasp. And there's three ways to install the screws. The typical one is perpendicular, where you install the screw perpendicular to the timber. The second one is where you made a milling, where you make a little hole indented. Usually is about, I'll say about a quarter, 9/16 of an inch into the wood. That way you're able to have the little nub of the wasp touch the wood. And then the other one is being inclined. where you install the screw 45 degrees or 15 degrees. Um, the Install the screw incline in 15 degrees. Usually the incline screws give you more resistance due to with the inclination it was is able to grab more wood fiber, and it will act more in withdrawal than shear. Withdrawal being just the pull out the screw, the strength of the pull versus how much will it take to to break or to bend for the screw. And one thing is always important to know about these installing these screws is to install them in dry surface, meaning that you have to make sure the screws are installed when the wood is dry, when the weather is perfect and it's not raining. And the reason for that is because obviously you don't want to run into an issue where the wood is wet. According to the NDS, actually, if you use the screws and install them in wet or when the wood is wet, it actually acts a reduction of 30%. So you want to avoid that, and so make sure to install the screws or any of the rigging connectors in dry surface. Um, and obviously you don't want to be working in the rain too. So especially lifting these panels in the rain too. So make sure they're installed in dry surface. And if you were to, for example, install them beforehand, and then take them to site, make sure those when those screws installed are protected. They're covered up because obviously even if it's installed and dry, but it rains later on, you have to make sure the reduction will still happen, and you have to make sure it is covered up and nothing is able to um, um, reduce the efficiency of the installation of the rigging. And so, just more pictures of how the WASP is installed. You can see how you may notice the little knob, right? Let me just show you. Just the pointer, right here. Like this is the knob I'm talking about. That's the thing where, uh, when 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 you're lifting up the panel, that knob is touching the wood, and it gives it a little extra push. And it just to be on the safer side too, because the last thing you want is the wall slipping out and then slipping out the screw. So it's just a way to prevent any slipping of the screws. So I talked about wasp and milling. So what that means is like what you do is that you make a little hole for a slot for the wasp, and I usually is about 2 inches wide and about an inch deep into the wood. That way you have the little knob like just touching the wood and is able to just give it an extra more resistant in terms of shear. That way now the screw isn't dealing the shear or isn't dealing the bending of the rigging. Now it's the wasp itself dealing with the force. And this will the failure mode here wouldn't be ductile of the screw or the screw bending. Now the failure mode here will be the wood being in compression, and usually when wood deals in compression, it is able to handle a bit more, handle more capacity. And so, and obviously this is a way to do it. Maybe just a way to avoid the screws sticking out of the wood. You want to keep them hidden, and also it can help you also as well, covering up the screws, preventing them from getting wet. You can simply cover it up with a membrane, and then at the end, when it's dry, the wood is dry, you can come in and solder and then use the wasp to lift up the panels or the beams. Um, and there's many ways to install them. You can for COT floor panels, it's as simple as installing them on the face beam. As for the beams, it's also as well, and you can also lift COT wall panels as well. But there's one thing to consider about COT wall panels is that you have to make sure that you install them in the right place. So meaning that you have to make sure the screws are perpendicular to the grain. So how I mean, you may know that COT panels have different directional grains. So make sure installing them in the perpendicular to grain layup. So that way you're able to get more resistance out of the screws. And so that's when and that's also important when lifting them up from vertical to horizontal, because you can do it. You can install the screws on the edge of the CLT and lift them up into a vertical direction. However, you have to make sure that you're installing them in the right layup. As you can see from the picture here, you notice that they installed the screw on the parallel to grain, and this led up to the layups breaking apart. So you have to make sure that you're installing the screws right in the area where you're gonna get a lot more wood grain out of it. And also one thing to note is that you must only use the fasteners one time, um, just for safety reason, because now the screw has dealt a lot of tension, has dealt a lot of shear, and now that screw is compromised. And so you have to go to be on the safer side, go in and replace the screw with another one. And also a couple of checklists you have to consider, especially when handling rigging. Obviously, the person who handles the rigging must be must be certified under OSHA. They're the experts. You don't want someone you don't want someone else just doing the job of someone who's certified under OSHA, especially when it comes to many experience of rigging beams and walls and panels. And so but just in case, you have to make sure that the area is clear and safe. All the elements are tagline. Um, Make sure there's no wind around, because obviously the last thing you want is the panel to swing around, and now you're causing more tension, more shear onto the screws, and worst case scenario, you're causing the wasps to deal more of the tension and more of the shear. Um, and also one thing to note is that you have to make sure that you're disposing the fasteners correctly, and not putting them next to the ones that have not been used, because the last thing you want is mistakenly use a screw that has been used already. So make sure that's into your consideration. And uh, two more things: you have to make sure the wasp is being lifted up correctly. So as you can see in the picture here, let me use my pointer again. You can see in the picture here, you have the wasp now being lifted straight. You actually have it see is slightly going at an angle. Um, this is something it's a big no-no, because obviously what you have is now the wasp is acting differently. Now instead of having the whole thing being used in tension, now you have a part of the hoop being used in tension. And um, it comes to any rig and connector, you can't do that. You have to make sure that all of the hoop, all of the ring hole is being used correctly. Um, and obviously you have to you can see that on this side we do say that you can use them in this direction, where you can lift them up in this way or at an angle. And so you have to make sure that when it comes to rigging, you install it's always straight or at an angle. If it's at a weight angle where you don't even know what angle degree it is, then safe to say that you're not using it correctly. And so make sure like you use the angles, the watts are being lifted at an angle that that you can tell, okay, this is like a 45 degrees, okay, this is like a 60 degrees, or this looks like a 90 degrees. So always keep that in mind. But now that you know how to use the watts correctly, now you want to know, okay, how do we know how much will it take? How much of a resistance can it handle? And so we can help you with that, because we were able to create a calculator, an Excel calculator to use when it comes to wasps. So here we have an Excel example where someone wants to use one of our fully threaded screws, the VGS11, and it's about 8 inches in length, and they want to use two of them, and they want to lift this this beam that weighs about let's say about 700. Wait, let's see, 1,000 pounds. Yeah. Um, so for this calculator, what you can do, there's two things you can do. You can choose your screw, what kind of screw you want to use. Like you maybe know, like, okay, I'm lifting a beam, I need only 2 wasps. So you can do that. You can figure out um, how many watts you need, and then you can play around and say, okay, I want to use a VGS 11, and then let's say 8 inches of length. You can do that. You just plug that in here. Um, it's also in metric and imperial, so you can if you guys are rely on imperial, don't worry. We have the US values here, and then from here you can plug in. Okay, I know the weight of the beam, so you can plug in the beam here if you want the weight of the beam here. Or but if you don't, but you do know the dimension of the beam or the panel, and you know what type of wood it is, it can actually estimate it for you the weight of the wood. So no worries if you don't know. We actually apply a factor to it. So that way, um, if you're playing not playing on a lower value, but you're playing at a higher value, meaning that you're okay. If if the actual beam weigh about 1,000 pounds, but we apply a factor to it just to be on the safer side, it will come out to be 1,500 instead. Just to give you the extra reliance. Um, and then from there, the Excel, what it does, it calculates the force for you, on trigonometry, cosine, and then the resultant force. It does all that math for you. And then that way we're able to determine, okay, what's the value of the watts and like of this force right here. What's the value of the force right here? And then at the end, that's what it does. The Excel, what it does is it gives you it checks to see, okay, which type of connector to use, whether to go perpendicular to grain, or what if we do a milling, like have the wasp milled in, or we go incline instead. As you can see, incline screw tends to give you a bit more of a resistance. The other option is the milling, because obviously now you have the wasp taking more of the force rather than the screw itself. And then you have the perpendicular to grain installation, where it does both withdrawal and shear, because that's what the screw is being dealt with. And then last but not least, we also check the capacity of the wasp itself. Um, yeah. So we have an Excel calculator for that. You can talk to the technical salesman for any. If you want to use the calculator, we can help you. We can glad you give you that access. But that's just the way of how much capacity to rig. Now you need to understand where it's installed in. So um, as you can see here, we provide guidance for the minimum distance from the edge of the beam, and also where to install them on the wall panels here. As you can see, um, you have the screws going in the area where it's going to be perpendicular to the grain. The same goes here for as well. For one is type 1, which is perpendicular to grain, and then the type 3, which is incline screws. We don't recommend milling here because, I mean, why would you want to do that? You're making it more complicated for yourself if you were to do a milling on the edge of the COT. Um, it actually will make it, because then you have to make a cut into the layups here. You have to make sure you do it correctly, because if you don't, then now you're messing up with the adhesion of the adhesion panels here, like the adhesion being used to connect the COT. Um, and then the same goes for right here as well. When installing these walls, make sure they're not in the lines. What I mean by that is like the lines, for example, like this right here. Um, the COT, because you're not grabbing enough fiber, wood fiber from the panel. You're only grabbing just a little bit. So go for the meat of the panel, or the middle between this right here. Um, that way you're able to get a lot more out of it, and you don't run into the issue of the screw not grabbing enough wood fiber, and you're dealing with reduction of capacity as well. And so this is just the wasp, but we also have another connector here that's for more heavy duty, and that is the Raptor. And so the Raptor, it's, say for example, it's like the wasp, but instead of having one screw, now you have up to 6 screws you can use. Um, what you is this red metal plate here, and we also provide guidance in how to install them as well. Um, Especially when it comes to metal to timber connection, you have to be very careful, because the last thing you want is the screw being over torqued. What happens when it's over torqued? Well, you just make the screw deal with more, you deal with more tension even before it is being rigged up. So this is why we always say right here that when it comes to moment insertion of the screw into the plate, make sure to go for about 18 feet per pound, like of power, and don't use impact screws. The reason for that is because with impact screws, it's a lot of torque. I don't know if you guys ever use an impact screwdriver. It's very powerful. I used one. I used one a couple days ago, and just to test it out, and it did not sound clean. It was very rough, and so always make sure that you're installing the screws with a regular wood screwdriver, power drill, no impact drill, um, and make sure that when the head is touching the metal plate, it's not into the point where like it's not like scratching the metal plate. You would know when you touch it, when you feel the power drill like stop, or you feel the resistance. If you keep going and you just like you say, oh, let me make it more tight, then don't do that, because now you have the screw in tension, and then you apply the chain here, and now you're adding more force into the screw. And the last thing you want is the screw to break while in the air. And so just make sure they're not over torqued. They're applied uh, as clean and nice as possible. And once it's done, you can easily remove them, which is also another thing. You're not over torquing the screws, because then now you have to remove the screws from the panels from the Raptor. And if you over torque it, now what if the head snaps? Well, great. Now you have a broken screw in the wood, and um, or the Raptor it got damaged. Now you got to replace the screw made with the wood and also the Raptor. You're just making it more difficult for yourself. So remember, just no impact screwdriver, and go as clean and safe and slow as possible. Um, and obviously, one more important thing is install them in dry surface. Do not install them when it's raining, when the wood is wet, or have the have the Raptor and the screws exposed to the rain, because now you run into the issue where now you have to apply a reduction into the capacity of the screw, or you also run into the issue where the screw, if it was over torque and rain gets into it, now what happens is that when you over torque a screw, you remove a layer and coating of the screw, and now with the water coming in, the screw is vulnerable and it can run into the issue of rusting. So I emphasize, do not over torque when it comes to metal to timber connection, and to always, always, always install them in dry surface. Please do not install them when it's raining, or when it's about to rain, or when the wood is wet, or leave the Raptor and the screws exposed to the rain. It will make your life easier, and it will save you a lot of money. And it comes to everything. When it comes to metal to timber, just make sure you protect the screws and you using them correctly. So that's enough of my rant. Then let's move on to the low direction when it comes to the Raptors here. And Similar to the WASP, you have to make sure you're lifting them correctly. Especially when it comes to this the loop here. I hope it's called a loop. I'll call it a loop. The loop here. You have to make sure you're lifting them up about 0 degrees, or in this case 90 degrees, um, up at a vertical direction, and not lift them up at an angle right here. Because now what you're doing to the Raptor is that now you have the Raptor lifting in one side and the other side is not. Or for the screw, like, so the screw right here is working in shear and withdrawal, while this side is not dealing is not helping the other side. It's just there. Or the other issue you might run into, which is also very important, is that you're not compressing the wood. This is a thick metal plate, so the last thing you want is that the when you're rigging, you don't want this side damaging the wood or crushing the wood. You want to lift them up correctly, where the only thing you have to deal with is the screw holes and not a wood face of the wood panel being crushed. And so that's why it's always important to lift them up correctly, vertically. Um, and so um, the Raptor actually has US values. Similar to the WASP as well, we can also provide you US values as well. But for the Raptor here, we actually created tables where you can have a look and see the different type of rigging capacity the Raptor has. For example, if we were to do a horizontal COT floor panel, um, you notice that when it comes to the Raptor, it doesn't matter if you have the Raptor facing maybe like um, straight 90 degrees or at an angle. For example, right here, what is important here is that when you connect it to the chain, it's following the direction of the force. So if it was like this and the chain is in the direction in the same direction that the Raptor is facing, then you can go with that. However, remember from the previous slide here, if it was facing in a different direction and the chain is in the other direction, um, you have to avoid this scenario right here. So just whatever you do, just make sure when using the chain is the wrap is facing the direction the chain is being lifted from. Just to avoid any complexity, and also to avoid having one side of the router take more force than the other. You want all of the screws being activated and to be engaged. And so this is for a COT panel on the floor. You can see you can use from 2 screws all the way up to 6 screws. And you can see here the type of screws to use. HVS plate or metal to screw connector. It's about 2/5 inch diameter and about 3 inches long. Or you can use the longest one we have, which is about 7 inches in length. And as you can see, when panels are being lifted up at a 0 degrees or just horizontal, you get more capacity out of it. But if you were to lift them up from a very steep angle, you get a reduction of capacity. So um, there's that. And also just note that there's a low duration factor of 1.25. So the values you see here have already been given a capacity factor, low duration factor, due to the application. So there's that. You can also use the Raptor as well for lifting from the edge right here. um, as you can see here, you can only use up to 2 screws. Is what we recommend. The reason for that is so that way you're avoiding um, any of the layups are where you have where if you were to install the screws, they're going to be parallel to grain. Or it might be that it's not sitting in the area where there's enough fiber to grab onto. Um, so we recommend going with 2 screws. Obviously, maybe if there's like a CFT layout where the screw holes are falling in the area where that screw will be perpendicular to grain, then you can you can see if it works. But better to send us your questions to us so we can double check, because the last thing you want is to do that and then all of a sudden the screws are not grabbing onto the panel from the edge as much. And one thing to note, as always, as I mentioned before, always make sure to lift from the loop, from the middle of the loop. Try not to avoid lifting the loop from just one edge of the area, or because obviously you don't want one side of the Raptor engaging more than the other. And so um, there's a scenario where what if the COT panel is on the floor, like instead of like having it vertical like this, what if it was sitting on the floor instead, like horizontal? There's you can what you can do is you can still go for it and have the Raptor installed on the edge right here. And what is assumed here is that you have half the weight on the one side and the Raptor dealing with the other half of weight of the panel. And then at the end, you get you have the COT in this position. Uh, to know the capacity of this, we actually mentioned it here in the parentheses right here. So um, obviously it's reduced just to be on the safer side, because now what happens here is that the screws are dealing with the shear force. So they're being lifted up from horizontal to vertical. Now the screws are compromised, and now you're lifting them up. So there's a lot of safety factor we have to apply to here. And so instead of saying, for example, you were to use HBS plate that's about 5 inches, 5.5 inches of length, you actually are using 981 pounds force of the Raptor. And just know this is just for one Raptor. So it's not just for the capacity of two Raptors, the capacity of for one Raptor only. So you can do the math. So if you have two, you multiply the capacity here by two, and so on and so on. So just have to in mind that when you're lifting the panels from horizontal to vertical, um, you're using this capacity in parentheses instead. So yes. And then what if you were to lift the panel differently, where instead of on the edge, you want to put it on the face instead, and you can go about in doing that. There's no one stopping you. You actually see there's a lot on job sites, on some job sites. However, one thing to keep in mind is that you have to make sure that when you're lifting up the panels, the angle here from the chain to the floor of the panel is less than 10 degrees. It's something recommended in any when it comes to the rigging industry. You have to make sure that you don't have the panels like um, say like for example, I have the panels like maybe we put the Raptors right here in the middle. Now you're lifting the Raptor. You might have the COT like swinging from side to side. So this is just a way to avoid the panel from swinging, or from, say, for example, like having the panels just like all of a sudden like go in this direction where it just lifts up and then goes down and up and down. It just becomes a swing. It avoids that kind of scenario. And we also have the capacity here as well. One thing to note here is that all these capacity, if we were to use a spruce pine fir, um, or wood with a specific gravity of 0.42. On a data sheet, we also mention um, what you can multiply this capacity with in order to deal with different type of wood. So if you were to deal with a Douglas fir, you actually add 10% of, yeah, you multiply this by 1.1. Um, just it's a factor we came up with, so that way you're able to know, okay, like, oh, I can go this multiply this by 2 because I'm using 2 Raptor, and I multiply this by 1.1, so I can know what it's like to lift a panel that's made out of Douglas fir, or a beam out of Douglas fir. So there's that. And last but not least, we also have the capacity for if we were to lift a beam instead. um And as I said before, and I say it again, again, again. Always make sure not to go at an angle less than 60 degrees, or in this case for beta, the rigging angle is beta here, or more than 60%. So if if you have the chain here going more and more here, say for example the angle here is like 15 degrees, beta here is 75 degrees. Um, Now what ends up happening here is that now you have the screws dealing with shear more than withdrawal. In order for these Raptors or any rigging connectors to be used efficiently and to be used at its full capacity, you want to make sure you're using more of the withdrawal side of the screws than on the shear. Because for those that may not know, shear tends to be give you less resistance versus a withdrawal. Withdrawal can give you one screw can give you up to 1,000 pounds of withdrawal capacity. It can give you a shear capacity of about 300 pounds. So you want to make sure you're using the withdrawal capacity more than the shear side. And it goes for any rigging connector as well. When you want to lift something up, you want to lift them up, with pulling strength. Um, for those who go to the gym, usually you can lift more if you with the pulling machine. But when it comes to um, maybe it comes to like compression, it takes a lot more force. Um, or say for example, another example I like to use a lot is like lifting a table, for example. You can lift a small table, like lift them up easily if in this direction, in a horizontal direction. But you may have difficulty if you have a table that's very long. You have to stretch out your arms more, and now what you're doing, you're actually making it more difficult for yourself. And so, always, always, always try to make sure you go for a 0 degrees, a straight up force, or maybe at a very small angle, not too much, because then now you're um, adding more stress, more strain, and now you're relying on the shear side of the screws instead. So there's that. And then we also provide some minimum distance as well for the Raptors as well. Um, One here we have on the CLT floor. Um, we make sure we always say like be 4 inches away from the edge of the panel. And when it comes to installing them from a vertical CLT wall to face, at least be 4 inches away from the edge, from the top of the edge, and more than 2 inches away from the edge on the side. The same goes for the COT wall on the edge side and to the on the timber frame as well. Or the beam. Be 4 inches away from the edge, and make sure the thickness of the panel or the beam is about 4 inches of thickness, more than 4 inches. So yep, there's that. And also one thing to know is that we also have an Excel calculator for the Raptor as well. Similar to the WASP, you can actually um, reach out to one of the salesmen. We can actually give you access to the Excel calculator. There's a lot of work to do because always there's a lot of way to lift up a panel. So um, this is just one of the versions. The final one will be uploaded on the website, or it will be easy to access, and it will help you with a lot of rigging scenarios. And here's some pictures of the Raptor being used, and also here's a video. Um, as you can see here, this is a project done in Colorado. You can see the Raptor they use 4 Raptors. And it's not being lifted horizontally. It's being lifted up at an angle, but that's okay. We did the math. It's able to lift up this very long CLT panel. As you can see, everything's done perfectly. It's on a dry surface. Very nice cloudy day, partially sunny day. And yeah, this right here is beautiful. Because you're obviously seeing the rigging here done correctly. Everybody's stepping away. No one's is in the way. and you see the COT panel swaying just a little bit, not to the point where like you're in danger. And you may notice that this beam is super long. What I did was I recommended going more towards the middle, but not too much, because obviously the last thing you want is the COT panels sagging a bit. If you ever lifted something very long, you may notice that the like a very long wooden beam, or I guess a very long stick, you may notice it starts sagging a bit on the edges. Um, you want to for when it comes to this type of scenarios, you want to avoid that kind of sagging effect on the panels, because then um, what was actually happening is that the screws are dealing with more of that force, more of that, more um, more of the shear forces. And so always try to be, I always recommend going a third from the edge into for like very long span panels. So, yeah. But those are like typical mechanical connectors. We also have a couple more. We have the Viper here, which is the your straps. We have four different colors, each one with different lengths, different capacity, and each have a safety factor of 7. So they're heavy duty. We have the Mantis as well. Um, it's just another strap as well, but you can reuse them. And it always has a safety factor of 7, and it can go up to 2,000 pounds. We also have the Dragoneer, where you make a hole in the wooden beam and the wooden panel, and you slide the metal rod inside, and you twist it around, and now you have a lifting strap that can take up to 1,800 pounds. And then just a video to show someone using the Dragoneer to lift up this on this panel here from the floor. And then last but not least, we have this another one called the OCTOPUS. Um, it's a lifting eye bolt, where what you would do is you make a hole into the wood, and you were to compress the wood with this eye socket here, and at the end you screw in the loop into the eye bolt, and that can give you up to 4,000 pounds of force. Um, People can go with this, but at the end, it all depends on how much uh, visibility you want on the panels. If you want to avoid any of the crushing, or any images where the wood is crushed, then just go for one of the WASP. Just you're only using one screw, or maybe you can cover out with maybe some wood caps. You can go for a Raptor, or the same goes for everything else as well. But it's just a matter of what you wanna, how much capacity you want to use. And as always, me and my colleague is always there to help you with these type of questions. So if you have, other than that, thank you so much, and have a good day. And just let me know if you have any questions.
Thank you, Alex. We did have one question in the chat that said that the website on the WASP was giving a 404 error and asked where to download the info. I just wanted to make a note towards that we noticed that right before the call as well, and have confirmed that the website is currently being updated, so it should be visible in a few hours here. And if you have any further trouble, you can always reach out to eng.na@rothoblaas.com, as you can see on the screen in front of you. We do want to thank you again for joining us today. If you do have any questions in a few hours, tomorrow, a week from now, a month from now, always feel free to reach out to the email that we have shared on the screen. And we also want to invite you to join us on future webinars. We're running these webinars once a week throughout this year, and next week and the week after for the remainder of June, we have site water management, and then we have a guest presentation with CAD work, digital design tools in modern timber construction, and then we'll be releasing our July webinars in the next few days here. So Thank you again, and we will talk to you soon.